Right. Morning, guys.
Good morning.
So today let's mostly talk about the rest of the assignment 3 of JavaScript. Last week we talked about the questions from 4 to 7, and today we're gonna continue to give you some help about the problems. Problem number 8.
Are you going to record it?
Yeah, I'm recording it. I'm recording it. Let me see if I still have the assignment folder. Yeah, I do. Just practice. Open with code. Alright, let's see. Problem 5, 7. Alright, let's see. Question number 8. So this one asks you to write the function time convert. It takes the number as a parameter and returns the number of hours and minutes the parameter convert to. And please separate the number of hours and minutes with a column. So this function is actually very easy. If you pass in a 61 here, time convert 61. So we're gonna output 1 hour, column 1 minute. It's gonna say 61 minutes. So if I say time convert 63, it's gonna be 1 hour and 3 minutes. If it's 120, it's which is 2 hours. If it's 59, it's 0 hours and 59 minutes. And some hints here. You can use in divide and a modular for a number 60. That's actually very easy. So for this one, for example, how to get the hours of it? If you're using 60, I mean any number, 159 divided by 60, and we need the whole number here. That means 2 hours and some minutes left. Right? And it's getting the hours here. You can using the function like parse int. Parse int going to pass in the number into an integer. So if you're passing like 265, it's going to be only 2. So you can just say parse int 159 divided by 60. And we know there are 2 hours inside it. And how to get the minutes? Think about the modular. Alright, think about the modular. Right, get the remainder within the minutes. That's for the question number 8. Question number 9.
That's all the clue we get?
That's already the answer. Write the function fileString. Takes 2 strings as parameter and return how many strings you can find in this long string. Assume string is not empty string. So, for example, in this one, you have high here, and you have a really long one. You're looking for how many high you have in this long one. So you have 1, 2, 3. So you get an answer 3 here. And for this one, you're looking for how many O you have here. You have 1 and 2. So you get a 2 here. And this one looking for how many har you have in A, B, C, D, E. There's none, so it's going to 0. And the last one, how many H you have in this one? Have 1, 2, 3. So the answer is 3. So it takes 2 parameters. The first one is shorter. The second one is longer. It's going to check how many shorter string you have in this longer one. Right. So for this question, you actually have 2 ways to solve it. Let's take a look at them. So for question number 9. Let's firstly, I really like to make the comments here. Right, just some description. So the function name is fileString function fileString str long. So we're looking for how many str we have long. So we actually can separate long into smaller strings and checking if they are equal. For example, the first example here. That's actually the second one. So we can separate this into single characters. We say, is D equal to O? No, it's not. So we don't do anything. Is A equal to O? No, it's not. We don't do anything. If O equal to O, yes, they are. So we're adding 1. If D equal to O, not, they are not. And we don't do anything. And is this last O equal to O? Yes, it is. So we're adding 1 to the answer. So this is adding 2. And also for the first one here, then you need to be careful, because we're going to check in if DA equal to HI. No, it's not. But we're not going to direct check in SD. We actually need to check in AS. The second one and the third one, is that equal to HI? No, it's not. Is the SD equal to high? No, it's not. Is the DH equal to high? No, it's not. It's HI equal to I. Yes, it is adding 1. Every time we only move 1 character, not 2.
Not 2?
Because if we're moving 2, we're going to check in DA equal to high, SD equal to high, high equal to high, DX to high, SD equal to high, AH equal to high, ID equal to high. So here we're missing the HI here.
Okay.
So you need to move in 1 character at each time. AS, HI. So every time you move 2, you're gonna missing some characters inside it. Right? And the way we start it, we're gonna first getting if we can get the length of the string, and we know like how many characters we're gonna compare. For example, if the length of this one is 2, so we're gonna compare with the first 2 here, and then the second 2, the third 2, fourth 2. How we compare it depends on the length of the string. For example, if I can get in variable length is equal to str the length, so I know the length of it is like either 1 or 2 or 3, and we can do a loop for we also need a place to store the answer. So variable answer is equal to 0. That means there's 0, and then we'll do a loop, and after loop we'll return that answer. So inside the loop, we're gonna start to loop it for variable I equal to 0, and let's say I smaller than long the length, and we also need to minus the string the length, because we are going to loop through from the first one, 0 stands for first index, until the last index minus the string's length, because like we're going to check in the characters inside it. We can comparing long. Let me see. I think we can do a split here, right? Let me try it. So if we do split, for example, if I say hello, the split 0, 2. Oh, sorry, not split. Maybe. Actually, it should be slice. Which one is that? Yeah, slice. Slice going to give me the. If I give 0, 2 here, it's going to give me characters from 0, 1, and before the 2. So what I can do here, I can say long dot slice. I want to slice it from the I to the I plus str length. So if the string length equal to 2, I'm getting the first 2 character, right? It's going to be 0, 0, and 2. And next time, when I plus 1 is going to be 1 and 3, and 2 and 4, 3 and 5. If that equal to the str, I will check in if that equal to xtr. So if this one equals to the string, and we're gonna answer gonna end in 1. Otherwise, don't do anything. So this is actually the answer for the question number 9. It's gonna need you to take care about the indexes, like when to stop it, and every time how we're gonna ending stuff, ending the length the string into the loop. And this is actually very hard to think about. And there's actually a tricky way to do it. It's gonna be much easier. So think about, we are looking for how many str in the long. How about I split this whole string? Depends on str. For example, if I split this one, the DO based on O, it's going to be, we'll split, we'll take a string, and if I put nothing, it's going to split it with, for example. So if I say hello world dot split, if I split based on the space here, it's going to be hello and world. If I put a L here, it's going to split based on the L. The things before the L, the things after L, and the things after L. It's going to be four steps because there's the two L's. Between them, there's going to be empty space. And if, for example, if I have DAO here, if I split it based on O here, it's going to be DA, A, and the thing after O, which is empty. That means we have two O's in here because we separated into three things. Now we know, like remember the things we ask you to here to finding how many str we have in long. If I'm using the O to split the long string into three parts, that means we know there are two in them, right? So if I got 3 items, a list of 3, and I know there are two O's. And for example, the first one, if I'm using HI to separate the string, it's going to be DASD, DASDA, and DASHI, or DASH, and there's empty after HI. So it's going to be 4 parts. Because we separated into 4 parts, so we know there are 3 HI inside it. Same thing here. If we use H separated, there's going to be empty space before it. That's the first part. Second one is I here. Third one is ELLO here. And the fourth one is O here. So we separate it into 4 parts. And we know there are 3 H inside it. So if we just do a split and minus 1, which is directly getting the answer. Just going to be 1 line. Alright? That is for the number 9. Think about it. Alright? Number 10. This is going to be the hardest problem we have in this assignment, number 10. It asks you to write a function, self-dividing numbers, taking 2 numbers, bound as parameters, and returns an array of every possible self-dividing numbers between them, including the bounds. It asks you, it's going to give you 2 numbers. Self-dividing number takes 2 numbers, like for example 1 and 22. It asks you to looking for all the self-dividing numbers between 1 and 22. If that is self-dividing, then put them in the list. Return the array. The definition of self-dividing number is a self-dividing number is a number that is divided by every digit it contains. For example, 128 is a self-dividing number because 128 can be divided by 1. It can be divided by 2, and it's also divisible by 8. It can be divided by all digits inside it. That is a self-dividing number. For example, between 1 and 22, 1 can be divided by 1, so that is self-dividing. 2 can be divided by 2, is self-dividing. 3 can be divided by 3, it's self-dividing. Like until 9, all the single digits, they are self-dividing. And 11 can be divided by 1 and 1, so it's self-dividing. 12 can be divided by 1, can be divided by 2, so it's self-dividing. 13 cannot be divided by 3, so that's not self-dividing. 14 cannot be divided by 4, so that's not self-dividing. And 15 is self-dividing, 22 is self-dividing. So we are getting all the self-dividing numbers between those 2 bounds, like between 1 and 22, and adding them to the array and return it out. Alright, so for question number 10 here, question number 10 here, we're actually going to create a function. It's called self-dividing numbers. Takes the left and a right. And we are going to checking other numbers from left to the right and check if that is self-dividing, right? So that's definitely going to be a loop because we're checking other numbers from left to right. And for this loop, we're going to think about when to start and when to stop. So I think we're going to start from the variable I, going to start from the left number. And when it stops, when I is getting bigger than right, when it's smaller or equal to right, we're going to continue it, right? And every time we plus 1 to the I. So we are getting from left and adding 1 until right. Right, that is what we're going to check it. And we also need a place to store our answer. Remember, we need to have an array. So store the answer. Let's add some comments. Loop over from left to right. This one, we need a storage store the answer. So let's have a variable solution. The solution is going to be an empty array. So every time when we found a self-dividing number, we're adding that number into the array, push that into it. And once we finish the loop, we just returns out the solution, right? So returns out that array. So you see, like there's many cases we're gonna have a storage store the answer, and each time loop we're gonna do something for this answer, and then finally we return it out. It's like a common way you're gonna solve the loop problems. So from left to right, what are we gonna check? We're gonna check if I is self-dividing. How to check if I is self-dividing? So we're actually going to checking this I. It can be divided by all the digits inside it, right? So for example, we're gonna say if this I, if I is, let me see, I'm gonna add this, if I is self-dividing, if this one is true, and then we're going to push that I into the solution, right? So the key here is how to checking if I is self-dividing. For example, 128. If we want to prove that it is self-dividing, we need to using 128 divided by the first character, divided by the second character, and divided by the third character, third number. Make sure that is modulo 1, modulo 2, and modulo 8. They all equal to 0. Then we know that it's self-dividing. So how do we do that? So if I get 128, if I try to split it, I cannot do that because that is not a string. So I need to maybe firstly transfer that into a string. There's a function called toString. Oops, toString. Does it really have a toString? Let me make sure about it. Let's see, JavaScript number toString. Actually, should have one. Yeah, num.toString does have one. 128.toString. Why is it not working? Serious? Let's try to put that in the variable. Variable num equal to 128. Num.toString. Yeah, I think I need to store that in the variable, right? And then I get a string 128. If for that toString, if I do a split with empty string, it's going to separate it into 1, 2, and 8. And think about it, if I can use 128 to modular that string's first one, and modular the second one, right? And also modular the third one. Do I need to transfer that into Let me see. No, I don't. I can just module the string. It's fine. I don't need to transfer it back to a number. It's going to treat it as a number when I use to the modular. So to check if a number is a self-dividing number, I can firstly transfer that into a array, and then using other numbers inside it to modulate it. How about we create another function to do it? For example, I can have a help function. Check if num is self-dividing. So I create another function. It's called is self-dividing. I can have be any number. Self-dividing. Takes a num, or checking if this num is self-dividing. So we can firstly, I got a num. As the example we just showed, we want actually firstly to getting all digits inside it. All right, get digits in num. So it's going to be variable digits is equal to num the toString the split is empty string. That's going to give us the array of the digits inside the number. All right, and next we can start to compare. Right, we can check. We're gonna check if num modular the digits zeros, ones, and twos. I mean, there's not going to be always 3 items. We don't know how many digits inside it. It might be 3 digits, it might be 4 digits, it might be 5 digits. So we're going to need a loop here to loop from the first one until the last one. So we're going to checking loop over digits. So for variable I smaller than so equals 0, start from 0. I smaller than digits the length. I plus plus loop over the digits. And we're checking if this num modular the I, not I, it's going to be digits ith item equals to 0. We don't do anything, right? But it's not equal to 0, we're going to do anything. So we're going to checking if that's not equal to 0, we can return a false here. And after for loop, we'll return the true here. So the logic here is if there is any digits, if a non-modular any digits not equal to 0, we're going to execute the code inside here, return false. And the return going to stop the function. And then we get a false. So we know that's not a self-dividing number because there's 1 digits cannot be divided by. And if all digits, if non-modular all digits equal to 0, then this return false never going to be executed because that's in the if. If this one always giving a false, we're going to never return false. And after the for loop is done, we'll return the true. Let's take a look at a real example. If num equal to 128, right? If num equal to 128, and the digits is going to be 1, 2, and 8. So variable I equal to 0 when I is smaller than digit length, smaller than 3, I plus plus, right? So if 128 modulo 1 not equal to 0, it's going to return false. It equal to 0, so it won't do anything. And then I adding 1, I becomes 1. We're checking if 128 divided by 2, that equal to 0, so we don't do anything. And 128 divided by 3, divided by 8, that's still equal to 0, so we don't do anything. And for loop is done. We're going to go to return true. And let's think about 129. So it's the same thing. 129 divided by 1, yes, it can, so it won't do anything. But when we try to use 129 to divide it by 2, obviously it's going to be not going to be 0. So we'll return false here. And because we'll have a return here, the function is stopped. And we'll finally return the false. So we know if that is self-dividing or not. Right? So this function is going to check in if num is self-dividing or not. And how about we use that self-dividing in here? If it's self-dividing I, right? If I is self-dividing, then we're adding I to the solution. Otherwise, we don't do anything. So that's going to checking all the numbers from left to the right, checking if that is self-dividing. If that is self-dividing, we add it to the solution. Otherwise, we skip it and keep going until the right number, and then we stop. All right, that's actually the answer for number 10. This is a little bit harder because you need two functions. Each of them going to have a loop. That is for the number 10. All right, so let's keep going to number 11. The rest of 2 is going to be very easy. Number 11, write a function move zeros, taking an array of numbers and move all zeros to the end of it, while maintaining the relative order of the non-zero elements. For example, if I do move zeros, 0, 1, 0, 3, 1, 2, it's going to keep the 1, 3, and 12 the same order and move 0 to the end. If I have 1, 2, 0, 0, 2, 3, 1, 2, 3, 3, 0, 0, those numbers, we're going to keep 1, 2, 2, 312, 33 the same order and move those 4 zeros to the end. And if I have an array of all zeros, not gonna do anything. If I have an array without zeros, it's not gonna do anything. So we're basically going to checking every item here. If that is 0, we'll remove it and push that to the end of it. If that's 0, we'll remove it, push that to the end. So we can have a loop from the first one until the last one. We're checking them one by one. If this is 0, we remove it and do a push. If there is 0, we remove it and do a push. Alright, so question number 11. So the function is called move zeros. Function move zeros takes a nums, which is array, nums. And as we said, we're gonna do a loop. There's actually many ways to do it. The easy way to think about it is like we can count how many zeros we have. For example, create a count zeros. So we can have a create a variable counter to count that how many zeros I have. We start from 0. There's no any zeros inside it. And what we can do here, we can loop over nums for, and also we need to place store the answer. That's going to be happens many times. Store answer going to be a variable solution. Right, it's going to be a empty array. And once we finish everything, we're going to return this empty array out. So we're going to have for loop for variable I start from 0, I smaller than nums, the length, I plus plus. We loop over the whole array, right, from the first one until the last digits. Then we can check it. If the nums ith item is equal to 0, we do something here. Else, we'll do something else. Like if that is 0, we're definitely going to add in 1 to the counter, right? We're gonna add in 1 counter. So we know there's 1 zeros, and if another 0 comes, there's the counter become 2. And else, if that is not 0, we can just cannot ignore it because we want to push that into the solution, right? We can push that into solution. Push it into solution. And then we have an array of solutions without zeros. Because every time when it's 0, we're adding counter. Not 0, we just push that to solution. And then we're getting an array of solution. And then I know how many zeros I have it. Then we according to how many numbers we have here, we're adding those number of zeros to the end of solutions. So we're going to have another loop here. That's going to be for variable I equals to 0, or actually we can say for variable I equals to counter, start from counter, and when I is bigger than 0, we'll keep continue every time I minus 1. So that means we're counting, it keeps subtracting the counter. And then every time we're counter getting smaller than 1, we are push 1, 0 into solution, right? We can just do a solution that push 0. And the counter, when counter equals to 2, it's going to push 1, 0. Counter equals to 1, push 1, 0. Counter equals to 0, it's just going to stop. And then, that's the answer. If you return the solution, that's going to be the answer. Right? It's actually not hard. Just going to loop over the array, checking if the number is 0, we're adding a counter. If that's not 0, just directly push that to the solution. And then, we're checking how many numbers we have in the counter. And each counter will add 1 to the solution, adding a 0 to the solution. That is question number 11, right? I didn't finish those parts. I leave to you. Question number 12. Create an average function that calculates the average of an array of numbers. That's very straightforward. So you have 2 and 6, and the average of them is 4. You have like those numbers, average of like 2 plus 4 plus 3 plus 5 plus 7 plus 10, and divided by the number of numbers here. The average is 5. That's actually very easy. If you can sum all the numbers inside it and then divide by its length, then you're getting the average. It's asked you what is the average of this array of numbers. So just plus all the numbers together and then divide by its length. To plus them together, you may need a loop. To plus the first one, plus the second one, plus the third one until the last one, and then divide by its length. That's it. Alright, that's the number 12. And that's all the questions. Alright, so the assignment is due on next Tuesday, so you still have about 1 week to work on that. And let me know if you have any question. I can explain everything again to you individually, step by step. Alright, that is assignment. I stop.